with your leadership, and you don't know how much we get inspiration because
Oh,
you have taken a consistency in your effort. That is what is most encouraging to us. That
thank
you
you
what
so much.
you have started, you stick to that. Perhaps you take lot of thoughts and then do something, start something. Thank you for inviting us, for giving us an opportunity. When yesterday you said, today, here this region is hit by a cyclone,
Oh,
Tana, and
mm,
now the rain just stopped, but roads are inundated.
oh.
Anyway, we are here at Institute, and we are very much thankful to you that you have given us this opportunity to discuss on such a very important topic of the day. Many things are important, but today we shall discuss and see that it is something special, especially important. Okay, let me switch off my. Sorry, I forgot to. Huh. And then everybody you are all requested to put your questions in the chat box. Whatever we can, limited time. How much time we have, madam?
So we can go on up to 2:55, and then 5-10 minutes it will be question answers.
Okay, madam. So if there is any question answer left, could not be completed in this session, then we would love to continue this association with you over email. Bhavna madam will
Yeah,
share everything with you.
yeah.
And this PowerPoint presentation, this we shall start, or what we shall do? How we should start, madam?
Yes, I mean, I think Shiv can present it. I mean, whatever is. Yeah.
Okay, okay, sir. I am presenting from my screen.
Okay, okay, okay. So as we start. So this is agrivoltaic. As you all know that it is combination of two words, agriculture and voltaic. Voltaic is obviously solar photovoltaic. So we know that solar photovoltaic systems are very much. Uh, oh no, Shiv. This is the old version. Okay, I am presenting. So I am sharing. Okay, see the latest one. I am sharing. No problem. Just a minute. Uh, where is that share option, madam? In this?
Yeah, that's the arrow that is shown.
Oh yes, yes, arrow. Yes, yes. Share the screen.
Yeah, in that
Yeah,
you have to choose.
yeah, yeah. Rest is okay. Yeah,
Yeah.
okay, no problem. Yeah. So yeah. Okay, now is it visible, madam?
Yes, it is.
So I can close this one. Okay. So F5. Yeah. Okay. So solar photovoltaic is very much important. We have the target, most of the new renewable energy addition that is going to take place in the solar photovoltaic region. We know that. And the perhaps the maximum investment, the percentage increase in investment also is maximum in this sector. But one thing is true for India, that we have less area, and that is a limitation. So rooftop solar, we have the target of some 40 gigawatt, and so and that is 100 out of total 100 we have a target. So all these things are there, but at the same time we also must realize the fact that this land is limited, and this agrivoltaic is coming as a solution. It is not a new term, it was there, but recently, as we know, that because of the scenario that is We need both food for the people, large population of our country, the largest democracy, most populous country of the world, and also the increasing demand and of electricity, and that too has to come through sustainable path. So both are made in this. That is why it is a special importance, special interest to all of us. So this has already been shared with all of you. Now this is a simple this picture that shows that where in some agricultural land, if we have the photovoltaic module at an elevated place, then we have the advantage of growing, continuing the this solar, this agricultural activity, and we can select the species that will grow even better under set, and also we can have the power, electricity generated. So even the same land, grazing land also, like in many places in India, Gujarat or Ladakh, we have lot of grazing land, West Bengal. So that also we can utilize, keeping the land as it is for grazing purpose. At the same time, we can produce electricity. So that is the outline of the presentation, that though there is huge opportunity, very interesting topic, but there are many challenges to overcome. And so we have set certain aims for our research and this presentation, and we shall show you briefly the methodology, how we have approached so far, and how at the end we shall also show you, after some analysis of data, that how we plan to go forward with our some acknowledgements. So the biggest challenge, as mentioned, that our increasing population and one of the lowest per capita availability of land, and that too one of the lowest, and it is decreasing at one of the highest rate of 45% decrement over last 30 years, because our population is increasing. And as much as almost 17 million hectare of land is barren. So that is a potential area for both agriculture and photovoltaic power generation. And this is what Madam has mentioned to you, that as much as 26,000 hectares of land are being used for holding the coal ash so far, and that is much as whatever we have generated, many of, maybe 90% of that are nowadays utilized, but still some remains unutilized, and they are occupying land, and so they are our direct target for agrivoltaic conversion. And then we have about 11 million tons of coal ash that remain unutilized. That is the latest figure from Central Electricity Authority 22 publication 2022, and there it shows that this much of ash needs to be disposed in a land. So if we can target the barren land with the help of this ash, then it is a multiple solution, multiple benefit from a single action. So like co-generation, tri-generation, so like that we can think of this multi-purpose benefit application. Now, due to increasing competition for land between renewable energy methods and agriculture, so here is a challenge, of course, because optimization. It will be more clear when we describe. So this is how you see that countries of the world. Australia is having one of the highest per capita arable land, but that too is decreasing. For almost all the countries, it is decreasing, and India having the lowest, it is decreasing even at one of the fastest rate, 45% over last 30 years. So you can imagine we are in a fix. India is in a fix in that way, that how to overcome this challenge. Now, the agricultural growth needed for this poverty, and sustainable development goal. The first is the poverty, how we can alleviate that. So there are 17 goals, and we can see that goal 7 is that clean and renewable, clean and sustainable energy for all. So that goal will be directly addressed, and also if we can overcome the challenge, the other goals also can directly or indirectly be addressed. Because we have the barren land that is yet to be utilized, and we have but worldwide only 2.8 gigawatt so far as of 2022 agrivoltaic installation has been there. And we have also, because it is already there, we have already identified that some of these many of the cases we have seen that because of the shading by photovoltaic module, those crops, they increase their yield. So that is the beauty of the proper selection of the crops. And that there will be semi-arid and arid regions. Because of this coverage, the evaporation loss will be less or more under control. So that will be the additional benefit. And India can achieve net zero target by 2070. That is our target, and that also will be addressed if we go through photovoltaic, these agrivoltaic paths that we shall see at the end of our presentation. So this is the aim, more or less. We have already discussed that this will meet the sustainable development goals, and there will be optimal solution. For it will not only produce the electricity, but it will, instead of reducing agricultural production will increase along with that. So the estimate of the potential we have tried to estimate, and we shall also show you that one of the pioneering work that has been done by GIZ with the help of the government organizations such as Indian Council for Agricultural Research and ISRO together. They have come out with some survey of all over India, and the potential also has been released recently. So though we were working for a few years, but recently we also saw their publication and found that it is interesting. So there is a need for plan for such a huge project, the need for implementation plan. And for that, one part is to have a demonstration project. So number of demonstration projects are there, and we shall show from our side one experience, because Damodar Valley Corporation, which is India's first multi-purpose project set up in 1948. So they have given a generous grant on research for this small pilot project of 5 kilowatt system. That also we shall show you more details about that. We are about to start that project also. So, and then the next part will be, of course, extrapolation at different level, because there are it will be difficult. It is not just copy paste kind of thing, because every region, every community, every locality of our country, they vary in so many ways. Some of them just listed which are more relevant for agrivoltaics is that of climate, the type of land and topography, the agricultural practice, prevailing practice by the farmers, then availability and pattern of solar radiation is different for different region of our country. Favorable conditions for growth of different agricultural produce just mentioned. Then farmers, they have their own generation after generation, some their expertise, niche application of different techniques and technology. So that also have to be respected and taken care of. The soil characteristics, local demand of electricity, availability of coal as fertilizers, etc., etc. So you can easily understand that such a wide variation, and we are looking for an optimal solution. Very difficult. Even I think that it is no doubt that such a all things are now digitized. Many things are digitized, we can say. That with the help of that, when those things will be available, digitized information, then even artificial intelligence also can help us to strike the optimal solution. So there are various aspects of use of coal ash in agriculture, agrivoltaic systems. So that is what we have found that even 100% that our PhD student, Shiv Sam, will show you that even 100% ash can also be could be used in local climate of Durgapur to produce certain vegetables. Certain vegetables they did not yield good, but certain did. So that he will present the research outcome. Then also he has done a survey in the local community, because we have the target that utilize the fly ash which is surplus unutilized in a barren land or where there is less of agricultural activity, how we can make that a fertile kind of land and also produce electricity. So we have also started surveying the surrounding communities and localities, and we are thankful to the Damodar Valley Corporation. We are going to start a pilot scale study and then extrapolate. That will be the next step. So over to now, see Sam. Yes, I shall change. You can start telling. I shall change as you continue.
Thank you, sir. So this is the map which has been created using GIS software, and in this you can easily see that the name of the village is Rakhaban, where survey has been done to assess the socio-economical conditions prevailing in that village. And you can see the name of the college where I had experimented and grown some vegetables, flowers, even jatropha in 100% fly ash and pond ash. And our prototype project would be carried out in DSTPS Andal, Durgapur Steel Thermal Power Station, owned by DVC. Next slide, sir.
Yeah. Yes. Please continue.
These are the project sites which I have already discussed just now. This is the college where we are doing the experiment, and this is the village where I had surveyed and got information important for our project, and DSTP Sandal, where we would be carrying our project work, and one visit has already been done. Coming to the assessment of the potential, so we are having 4 targets. So coming to the target 1, so the land which is presently being used to hold the huge amount of ash generated from the power plant. Coming to second target, disposing of unutilized ash from all the coal-based power plants to the barren lands for agrivoltaics, innovative applications. Coming to target third, so we can use 0.1% per year of this much hectares of land that is barren and which is not viable for obviously agriculture, and we can treat it with advanced agrivoltaics techniques. Coming to target 4, so application of agrivoltaics in existing agricultural land in a proper selective manner, let's say 0.05% per year. So we can augment the productivity of land and generation of electricity as well for local microgrid. This is the graph where you can see capacity projection of agrivoltaics. Now we know that India is blessed with almost 300 days of sunshine a year, and we also have huge amount of land which is under agriculture. And but agriculture in India depends on number of factors like rainfall, proper irrigation facilities, fertilizers, economical, financial conditions. So I think we have huge potential to implement our project in a proper manner. And as you can see in the graph as well, that the projection for from 2024 to 40, that it is obviously going to increase, and we are hopeful that our project would be a boon for the society and the farmers as well. Coming to the analysis part, so we are assuming that 1/3 of the area under agrivoltaics would be utilized by vegetables, flowers, and medicinal plants. So this is the data related to the normal market conditions prevailing in our area, and related to vegetables, their market prices and all, and how much employment and can be generated uh, by the farmers. Also, regarding medicinal plants, also the data is same, and for flowers also, uh, the data is related to the certain market conditions prevailing in our area. Next slide, sir. Now coming to the result discussion and some of the achievements. So we'll be going through the prototype demonstration on agrivoltaics for selection of species, then testing uh, of the species, testing of the food for pollutants like or heavy metals, etc., and highlights of the survey of the village, estimation of the availability utilization of land in India for agrivoltaics use, and estimation of the impact of agrivoltaics implementation in India. To the some preliminary outcomes and results. So some vegetables and flowers have been identified and grown in normal condition, in normal local climatic condition, in 100% fly ash and 100% pond ash, and some vegetables have shown quite overwhelming positive results. Some flowers, even jatropha has shown quite good results. So like vegetables like brinjal, lady's finger, radish, tomato, these show quite good results. Flowers like Jui, Bailey, Nandini, etc. And jatropha is currently jatropha is growing, and it is also showing quite positive results. Survey of the village has been done, and it has revealed that the socio-economic development is quite possible through the implementation of our project, because the condition in the village is really not good related to electricity or water supply or irrigation or rainfall. Even the fertility is not that good. So site survey for pilot scale study in the coal-based power plant of DVC has already been done, and extrapolating the outcome of the extrapolating the outcome to rest of the country might reveal huge potential. So these are the pics of some of the flowers, vegetables, and jatropha which I have grown in fly ash and pond ash, and they have grown quite positive results.
You also name some of them.
The flower is Bela, and lady's finger is there, jatropha on the left hand side below, and then brinjal on the right side, and radish on top right. And this is the so after growing the vegetables in the fly ash, I had also sent the sample for the testing, and the report showed that the brinjal was safe for human consumption.
This is because there is a common saying that the fly ash they contain heavy metals. So anything grown in fly ash, particularly if it is 100%, there is risk for contamination. So that is why we took this measurement and this test done by government authorized laboratory.
This is the highlight of this survey of the village where I had gone to visit. I found that the water availability was only dependent on rain for the crops. Fertility was really poor, and they only could grow rice, a single crop for whole season. Electricity availability was only 4 to 5 hours. Most of the people were not earning their livelihood from agriculture. Most of them were engaged in construction activities like construction of houses in nearby towns and cities, construction of some malls, stone quarries, stone chips, etc. There is one school in nearby, primary school. There is no hospital in the vicinity area. They had to walk or go to some 8 to 10 kilometers. And bus stop, hospital, market were quite available there. Okay, sir. Please continue, sir.
Okay, so thank you, Shiv. Now we have, as we have been telling, that this project is not only just energy or food, it also has many good effects like the carbon dioxide abatement or absorption, because we know that that plants absorb carbon dioxide. So if we can grow plants in the barren land, so it is also absorbing carbon dioxide to the tune of 1.5 kg per meter square per year or 15 ton per hectare per year. Similarly, electricity generation will also be this much is the average figure, but this will be different for different location. And this will also have engagement, job opportunity for 4 to 5 people per year per 1 hectare of land. So that is the uh, benefit. Then we also have this, how much, because of the solar power generated, so this will avoid the burning of fossil fuel. India, as we know, about more than 60% of electricity generated comes from burning coal. And so if we consider that is avoided, so that will mean that it will also avoid, say, this many tons of CO2 emission. 1,772 tons of CO2 emission also. Now we have today we have focus of 2 points, that is already there is fly ash in about 26 plus thousand hectare of land. So if every year we target that 10% of that land we go switch over to agrivoltaics, then what will be the effect? And the second is that the barren, the fly ash which is going to be unutilized, that the report we have shown you, that there is a significant amount of fly ash which is going to be unutilized even today. So if that fly ash, if we distribute in over a barren land nearby, so that is of course another challenge that not yet mentioned, that is supply chain management challenge, on which Shiv also is an expert. So that will be an issue to identify how most efficiently we can transport the excess fly ash to a nearby barren land. And that also is an opportunity to produce electricity and go for agriculture, so agrivoltaic. So that is another area, and we have assumed here that 3 feet will be the layer depth of the fly ash or ash which is unutilized, is distributed over barren land. Then this much hectare we shall be able to go, and we have divided that into 2 parts. So total is 786 hectare every year. And if we go for 50%, that is a standard practice. It can be less, it can be more. So in all the calculations, we have assumed that 50% of the land is covered with photovoltaic module. Okay, so we get the with this we calculate that how much electricity can be generated, how many people can be engaged, and also how many CO2 can be emission can be reduced. So the other two things, which is not today's focus, but it also is a huge opportunity. In the GIZ study, you could see they have also arrived at similar outcome, that also this we had done last 1 year or so, but similarly they have also come out with a report this year that if we go for at least say 0.1% of the existing barren land, which is not very difficult. So India's total barren land, if we 0.1%, if we target every year to convert to agrivoltaic application, then this will be the achievement. Obviously, they are bigger than the previous scales, and also even 0.05% of the existing agricultural field. And that we have made a modest target because this needs lots of research because of so many variables. So if we can target even 0.05% of the agricultural field covered with solar photovoltaic, so how much? So this project will continue for maybe 2000 for the country, 2000 years. But see, every year we have a even much larger outcome in terms of solar photovoltaic land, in terms of agricultural land. Okay, now we have plotted here. Actually, first we have calculated on Excel platform that what will be the corresponding CO2 emission. That is the major achievements out of the project, that CO2 emission mitigation, employment generation, these people will be engaged, and then the power generation. So these five parameters we have calculated for each of these four types, and then actually these graphs will be easier for you to understand that this is the type 1 land, this is the type 2 sorry, this is the CO2 abatement for type 1, type 2 and type 3, and this is a different scale, again the CO2 abatement, but for type 4 land, and then this is the total. Similarly, here the employment generation persons per year. So this is the type 1, type 2 and type 3 employment generation, and then this is the type 4 and this is the total. Similarly, the coal burning, avoidance, electricity generation, income generation. So when these are put on a national scale, suppose in India we have now means in 2020 data we have that the emission is 3,201 million ton per year CO2 greenhouse gas emission, CO2 equivalent. Okay, now we have seen that these type 1, type 2, type 3, type 4 all put together will reduce CO2 emission by this much, 349 million ton per year. So it will take about 9 plus 9.2 year, about 10 to 11% per year mitigation will be there. So we can achieve net zero, but actually demand also will increase by that time. So maybe we shall achieve net zero a little away, further away. But these are the very much encouraging figures. Similarly, employment generation, of the total employment we have in India, so this effect can produce this much of employment. So this is 2023 data, and this is, you can see, this is also 3.6% of the total employment. Is not a matter of joke. And you can see it may take 27 years for all the people to become in that sector, but that is not desirable, just a figure. And here also the income generation, and then you can see electricity generation. So we can completely switch over to photovoltaic power, those storage issues, etc., pending those problems to be solved. So this is possible that all the power from photovoltaic can come in 43 or so, 43 years, if we consider the present this requirement, which is now 1176 billion unit we have consumed in 23-24 according to CEA. So this is another very much encouraging data for us. And coal consumption for electricity, that also will be reduced. It maybe within 4 years also we can avoid that if we adopt all the four types. So that is what is the overall for the country, but it is not so easy, definitely. So in conclusion, we can say that the proposed model of using coal as a soil amendment or replacement in agrivoltaic system has a demonstrated potential. So this is not ours. We just saw recently, we, thanks to our one of the alumni that shared, there is a report of GIZ that we saw that they are also giving similar or encouraging output, that if we as a country can take up a long-term plan, then this net zero or switching over to sustainable sources, renewable sources, so that is not difficult at all. Difficult is, of course, to implement the plan. The result from the study indicate that agrivoltaics combined with this use of fly ash or coal ash, because we have adopted that coal phase down plan. So in that process, coal will continue to dominate at least for a few more decades. So what is the plan for better or sustainable use of that coal ash? So again, we can look forward to agrivoltaics method. And there we have seen that it is possible to achieve net zero also by 2070. It is not a far cry for our country. So with this, we have, as we have mentioned, that we are thankful to, hello? হ্যাঁ, আমি না ওয়েবিনারে আছি এখন, একটা ঠিক আছে পাঠিয়ে দিন। Sorry, the director's office has made something important. Now, see, there are many things way forward, and of course, the policy is the most important thing. And for that, we are all here, because no policy can become or see the light of the day if we do not all want that to happen. So, if we all are convinced and we all want, then policy will come and policy will be implemented. So, and we are sure that there will be many more people will come forward in this research field, because each region needs some independent research, because each region, each location has different parameters, combination of parameters. There cannot be a single solution, right? So, developing a platform for a software tool will be, of course, the matter of time. Very quickly it is bound to come, particularly in the age of artificial intelligence. Then capacity building and training will be must, and I think the young population of India will contribute to the maximum, because we have the largest young population also of the world. And then pilot project, we hope that our small project also will be successful. We also pray to all of you that you also have your good wishes and goodwill, because that is the for Shiv, that means a lot, not only his PhD but also his future career, because he loves this area, and lots of challenge is there. And then we have the monitoring and evaluation of these projects, and collaboration and opportunities. We are open to collaborate with various like-minded organizations and persons who are, because together we can go ahead, together we can succeed. This is the pilot project plan we are going to implement very soon in under DVC, completely sponsored by DVC. And you can see that we have these sectors of land. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 modules, each of 500. So total it will be 5 kilowatt system. And then there will be under that, because they will be spaced equally, so that the 50% or so area will be covered by modules, 50% will be open. That is average scenario, but we have seen even 100% cover, like the betel leaves. There we can cover almost 100%. So it depends on the species, but we have taken an average case for the startup. But starting, and later we have an adjustable system. We can close them, or when required, more closely we can space them. And then we have the reference case also, that open space. So we shall compare the growth under solar photovoltaic and in normal scenario. And we shall compare also with normal soil and pond ash and fly ash. So all these things we have the plan for various, at least for 10, 15, 10, minimum 10 species, including the medicinal plants, flowers, and energy plantation like Jatropha. And let us see what happens. So this is our overall plan, that vegetable biodiesel like Jatropha, flowers, and medicinal plants, and we have kept one empty space for more study like betel leaves and all. Yeah. So that is the reference case with normal plantation. And as the species that we have already identified, as you have seen the picture shown by Shiv. So amongst those, we have now made a study and we have seen that harvest time is different. So we have to have a proper combination because their seasons are different. So to maximize the utilization of land, also we have to cycle them in a proper manner so that they can be utilized, the entire system facility can be utilized to the maximum extent. So this is our acknowledgement to our institute, who has always been a support. Then to our director, to Damodar Valley Corporation, even before sanctioning the pilot scale research project, they have been helpful. We have a joint action team for research in various areas. So particularly we are thankful to Dr. Khankari, Dr. Rajan, Mr. Dinesh Kumar, Mr. Dr. Sen, of the Damodar Valley Corporation and Tennessee Valley River Authority. We met them recently in AE World, in where we present the Agrivoltaic paper, because Tennessee Valley Authority, they are the inspiration for Damodar Valley Corporation. So they are also going for agrivoltaics. We are happy that they also agreed to share their experience in USA, though it will be a different climate, different setup, but we look forward to their experience also to know more about the application of agrivoltaics. So now we are open to question. We are ahead of time. 5 minutes extra may be available for question and discussion. Over to Madam, or over to Shiv if you want to add anything, and then to Madam.
Yeah. Yes, Shiv, are you adding something?
No, ma'am, but we are hopeful that we can implement our project, and I would like to take take the question answer session as well with the help of sir also.
Yeah, sure. Sure. It was very interesting. And secondly, I mean, if really this can be implemented in a wide way, so that will be great. My question, I mean, Shiv, to Shiv, he being from the logistics also. I mean, he specializes in logistics also. So how this, I mean, transport of this coal ash can be done effectively? Because while transportation, I mean, how is that logistics taken care of? Can you tell about this?
Ma'am, currently fly ash is mostly transported through road sector, and road transportation is quite costly due to economies of scale. And there are actually, I had also presented a paper based on the particular transportation issue of fly ash at Kodarma Thermal Power Plant in Jharkhand. So there, when I had visited that power plant site, so what I could find that too many accidents due to the frequent dumpers and hivas on the road, too much pollution, So these were the issues. So one experiment railways had also done, that they were sending fly ash through box and that open box rakes. So what I had suggested in that paper, that the box and rakes are generally used to bring coal from the coal mines or merry-go-round, whatever system it is, to power plant side. So if reverse logistics can be applied, if the same box and rakes can be applied to send fly ash to different sites. Now, dedicated freight corridor is also almost operational till Sonnagar in Bihar. So maybe that particular that dedicated freight corridor can also boost this particular transportation and logistics thing. But currently, road transport is having major chunk of fly ash transportation. Railways, on an experimental basis, NTPC Rihan and I think NTPC Vinnagar, they had sent sent fly ash to some areas in northern part of the country in NCR. So we are hopeful that some more innovative, even pipeline system have also been tried, that can be also in the mixed with the fly ash, mixed with the slurry. So pipeline transportation can also be a sort of better way of transporting fly ash without compromising the ecosystem, because in normal cases the whole ecosystem is disturbed from at the places where fly ash is being transported.
Correct. Yeah. Thank you, Shiv, for that explanation. And now I take up the other questions. We have questions from Mr. Sanjeev Sinha. His question is, I have heard that coal ash can have significant traces of arsenic, lead, thallium, mercury, uranium, and thorium. Is it true? How does this impact usage in food production? And he has given example of coal from Australia would have higher radioactive content.
Yeah. Okay. So we would like to share the screen again, where we actually quickly rushed perhaps that there is a slide which shows that we have, this is a very pertinent point. Thank you for raising this point. We also faced this question during our research and from including DVC people also. So we took it seriously, and we have picked up some samples which were grown, lady's finger, brinjal, grown in that area, in that fly ash, and then taken to the government recognized laboratory. It is a very costly, 5,000 rupees was the charge. So this is a costly test which is done to detect whether such any what you have rightly mentioned, you are correct, because they contain these types of elements and heavy metals. So whether the food, that vegetables are edible quality or not. So they have made that test, and they for everywhere they have pointed out, reported that there is nothing such detected. Maybe it is our wild guess that the plants have the, actually we are made for each other. Whoever is the creator, may it be God or whatever, plants or animals, they are made for each other. So what we reject, they accept. It is their need. And even carbon dioxide we reject, they take. So, and what they reject, we accept. It is good for us. So now maybe that system is inbuilt, and so the harmful things are not absorbed by this. At least the test showed, but we shall not stop. As you also have pointed out, we shall continue to do in the project. We have allocated some fund for this purpose, that we shall continue over the 1 year. Whatever is grown, we shall again test them and get perfect. 100% confidence is required. One test is not sufficient, we agree. So that is the status. If you have further query, please be in touch, or please you can ask more questions.
Sir, I would add
Yeah,
that in India, most of the bituminous type of coal is found. So in that type of coal, mostly calcium, silica, alumina, these kind of chemicals are found as per my knowledge.
Yeah, you are right. But what he said is that is also right, that they are those arsenic, those are in very small quantity, heavy metals. So they are in very small. It is present. It is the nature. By nature, all coal will have, maybe it vary, but it will be there. But plants have not taken, absorbed them, and it is not reflected in the fruits, in the product of the plant.
Okay. Thank you, Dr. Binoy and Shiv. Now, next question is from Ma'am Roshni Isa. So her question is, in agrovoltaics, the plants grow under the PV panels. So what is the effect of absence of direct sunlight on the plant? And also she's asking that fly is used for brick making. So it's not really a waste material.
Both points are correct, but these are relative truth, not absolute truth. Because you see, betel, we shall give one example, that betel leaves, pan pata, which you know, that pan. So those leaves, if you have noticed, they all grow under a boroj kind of thing. It's a totally enclosed environment made of bamboo. Only little bit of light through the gaps it percolates. So it is the fact for many other, like potato also. Japan has many such published results from Japan, that when potato is grown in open sunlight, then with all other things in favor, nutrients and water, even the seeds, all everything is in favor. They have maximized the production, and then they have covered with photovoltaic at certain intervals. Then also they compared the production has grown. So this is because that some but that will not happen in case of sugarcane, for example. So sugarcane is a kind of plant which needs more sunlight actually. So even if you reflect radiation with some mirrors, the yield may be increased in case of sugarcane. But there are many other plants where if you can reduce a bit, then the yield will increase. So that is the matter of research, and that is the area of our focus. That a part of our focus, that how we can find optimal solution, and it will vary with climate also. And the second point, that what you have mentioned, that they are utilized, it is true. Fly ash is being utilized, and still it is remaining unutilized. That is the published report from Central Electricity Authority. Maybe there are some logistics challenge, or maybe some challenges there. It did not happen. Fly ash is extensively maximum use in the cement nowadays. Fly ash is used even in land filling, in brick making and whatnot, but still about 10% is still not utilized. So those are the area where we are looking for. We want to make it 100% utilized.
So, sir, I would like to add that we are also focusing on pond ash also, because there is a huge
Correct.
amount of legacy pond ash. So fly ash is anyways most of the time utilized in cement plants. If cement plant is in the vicinity, as per government notification, 300 or something like kilometers is there, that road transport should be in that range only. So more pertinent issue is the pond ash, because pond ash is not as much it is not being used in cement plant due to its properties, and also it's not being used in making of bricks. That's why we call it fly ash bricks.
Thank you, Shiv. I hope, Roshni ma'am, that clarifies your question. And now another question is from Mr. Sanjeev Jain. And welcome, Sanjeev sir, to AEE Western India chapter. And his question is, thanks for nice informative presentation. MNRE has already introduced agrovoltaic under PM Kusum. and solar plants on ash dikes. But due to implementation issues, progress so far is not encouraging. So,
Yes, sir. Yes.
yeah.
Yeah, Sanjeev ji, thank you for pointing out the PM Kusum program of the Government of India. And under that scheme, they have given a task to GIZ, who, with coordination with that of ISRO and Agricultural Research Institute of India, they have come out this year only, January. They have released the research. I can share with you if you have not got. I think you have also got. So they have shown there are problems. Of course, there are challenges. Progress is not much. You are right, but they have shown the potential huge 3,000 gigawatt is the minimum percentage of application, and 18,000 gigawatt if it is optimistic. Means scenarios, as you know, it can be very low or medium or high. So optimistic scenario 18,000 gigawatt potential, even pessimistic scenario also 3,000 gigawatt. So that is the potential, and progress is not there. Implementation issues, obviously, that is the awareness the farmers, because for smaller systems SMEs have to come up, startups where the farmers will be the. I have been fortunate to visit one village in Germany which completely runs on renewable. Not only that, 7 times of their electricity they produced, what they need, 7 times of that they produce extra and export to the grid. And all the projects, they have the photovoltaic, agrivoltaics also to some extent. That time it was not. I visited about 10 years before. So then wind and biomass, they have their cattles, and those cattle dung they are collecting and putting in the large biogas plant, and the fertilizer, organic manure being utilized. It is a complete ideal village we normally think of or discuss about, and that I could visit that really doing. And I was more, it may happen, I was not surprised, but what I was surprised that all the projects are owned by the local community, the farmers. They know each other, and so much nice coordination among the local community. All are SMEs, small projects. They are all like startups. So just a dream. So that if that happen, it may take some time. Then definitely India also will sign.
Yeah, thank you, sir. I hope that clarifies. Mr. Jain, like if you would like to further ask something about it, you may speak. And the next question is from Kuntal. Yeah, Mr. Jain, are you there?
So good evening, madam. Good evening.
Evening, sir.
Good evening, sir.
Thank you, Choudhary ji, and thank you, Mr. Sridayal ji. In fact, I was in the field since last 40 years and implementing the various scheme of Aminari. And a few years back, in association with the Chhattisgarh State Power Generating Company, we have already identified about 4 megawatt on their ash dike, and we have floated the tender. But unfortunately, we could not get any response from the bidder. What was the reason? I don't know. As I have already mentioned, and you have already clarified that as power plant on the ash dike, it was MNRE flagship program. But what are the reasons? I don't know, because there is a lot of scope. The land is available, ash dike is available. So it should be definitely utilized for the solar power plant to achieve the net zero target. And as have you mentioned that the Kusum A scheme, so that was the idea of the MNRE scheme, कि किसान को अन्नदाता के साथ ऊर्जा दाता भी बनाना है, so that he can get more. agricultural income from their land and additional income from the power generation. So far, progress under the Kusum A, under specifically on the agrovoltaic. It is very, in fact, it is very potential sectors, agrovoltaics. It should be promoted, and we thanks to you and your research, you will definitely convey your conclusion to the MNRE to get implement in the field. Thank you very much.
Thank you, sir.
Thank you,
Thanks.
sir. Thank you.
Um,
We would love to be in touch with you, sir, through
Sure.
Bhavna Madam, through Western India chapter.
Yes, sir. I will share my detail also.
Please.
So there are some more questions, but I think we have crossed the time. So I will definitely convey these questions to Mr. Binoy Choudhary. And regarding
Yes,
presentation, I will be we'll be sharing on our YouTube channel, that is AEEWI Western India is the channel that we have, and we upload all the presentations on this channel. So you can see the presentation over there. And those who have missed the session can also have a look at it. Yeah, thank you so much for joining, and we hope that you continue attending the sessions. So this is 44th session, and we are completing near about 2 years now with the session, and hope we continue it next year also. Let's see. And yeah. Thank you so much, Mr. Binoy, Mr. Shiv, for this. I mean, it was so much at the 11th hour, it was conveyed to you, and still you accepted our request and made it possible by adjusting your schedules, and you made it possible. Thank you so much for that.
You are so much respected, madam, to all of us.
Yeah.
We shall always be with you. Thank you.
Thank you so much. Thank you so much. Thanks.
Thank you. Thank you.
Thank you, ma'am, for giving us the opportunity.
Welcome, and all the best to you and for the future also.
Thank you, ma'am.